I would like to welcome you guys as well to Plant 3D versus Revit MEP. Today's agenda will give a brief introduction of our presenters and the webinar topic, and then we'll get straight into program deciding features such as isometrics, import and exporting, design options, P&IDs, and more. Then we'll get into other features such as project phases, piping components, structural design, and interoperability. Then with the time remaining, we'll try to get into some live demos to show a little bit of the spec editor for Plant 3D and the family editor in Revit, and then we'll open the floor up to some questions.
Hi everyone, my name is Paulo. I'm the guy on the left. I'm a Plant 3D and Revit instructor. I joined IMAGINiT about 3 years ago, approximately. 10 years of professional experience in Revit and Plant 3D, and I have a background in chemical engineering. And on the right is my friend Javier.
Yes, my name is Javier Jones. I have multiple years of plant experience. I am also Autodesk certified in Plant 3D, and I have field experience in piping and P&IDs on the mechanical engineering side. Also, if you have a little bit more time on your hands, we do have another webinar that was posted in 2020 that compare to contrast Plant 3Ds. We're going to be hitting on some different topics than this one, but if you do have the time, go ahead, check out that link. It is a very good IMAGINiT webinar on the same topic. So for today, some of the Plant 3D features will be focusing on plant design, which is built on top of AutoCAD, enhanced P&ID drafting and 3D modeling, automatic generation of piping isometrics and orthographic drawings from the 3D model. And then for Revit, we focus in the building design, tools for architectural structure and MEP disciplines, parametric components to modify building elements, enable multiple users to work in the same model. A lot of times, some of our clients ask, we're using Revit for all disciplines except piping design. Can we use Revit instead of Plant 3D for process design? Some reasons behind this question being desire to keep the entire project in a single program, access to the piping data from inside of Revit, better overall model integration, no need to train designers in 2 different programs, no manual exports to refresh the latest models. So as we're speaking of here, we know that Revit can house HVAC, piping, electrical, some architectural, where Plant 3D mainly focuses on the piping and equipment side with some of the structural. So we'll right into the program deciding features, a brief comparison of some features that one or more programs supports more extensively than others. And I just want to remind you guys that this is based on our personal opinion and some of the experiences that we've been through. So let's get right into it. The first being the creation of piping isometrics or ISOs. For Plant 3D, we gave it a 5 out of 5. Specializes in automatically generating isometric drawings for piping line numbers. Includes tools for creating, customizing, and managing isometric drawings effectively. For Revit, we gave it a 0.5 out of 5. Creation of piping isometric drawings is not automated, and the process would be mostly manual. Add-ins for isometric generation might be available. Here is a ISO from Plant 3D. As you can see here, you get the bill of materials, all the inline components and piping components, even instrumentation is numbered. So you're able to identify exactly which piece is being named. You also, if there's a very long spool, you can have the quantities and then also the long description if you fabrication or somebody needs to take a look at it. All the extra features you see down here at the bottom being the drawing name, number, service. These are all properties that can be populated and added into the drawing. So it gives you a lot more customization for isometrics. Just some of the isometric customizations are symbols and reference, ISO setup style, the default settings, themes, annotations, dimensions, slopes and offsets of piping, and then your title block. As you can see here, if you're getting kind of congested in things in your ISOs, you're able to turn things on and off and get it exactly where you want it. And as I was saying here, for your bill of material or spool list, it's almost as if you're working in Excel. You get to move around your cells and use macros and add and delete columns or rows. You also have a couple of options in your ribbons at the top of the Plant 3D and some extra fields that you're able to fill out to give it exactly the customization that you would like. Next, I'd like to talk about exports to PCFs, which are piping component files. For Plant, we gave it a 5 out of 5, as it's very easy and possible with just a click of a button. And we all know with these piping component files, if you're unable to send over a full drawing and you just want to send over the PCF file, this will give you a space to let transfers and emails and things be a lot smaller versus sending a whole drawing. And for Revit, we gave it a 1 out of 5 because a macro is needed for PCF export and only for piping fabrication parts. To import a PCF is just as easy. You have the option for PCF to isometric, which is very handy, and you also have the option for PCF to a piping file. For Revit, we gave it a 0 out of 5. That is not available at this time. When it comes to design options, Plant 3D, we gave a 2 out of 5. There are some workarounds through new files and layering and XREF to be able to have multiple people working on a specific area or drawing. But for Revit, we give it a 5 out of 5 because there is a very robust design option feature enabling multiple design scenarios and a very easy comparison. For validation of your data, for Plant 3D, we gave it a 4.5 out of 5. The built-in tool for validation data consistency between P&ID objects, 3D piping, and 3D modeling to P&ID checks. As you can see here, some of the main ones are for P&ID objects, size mismatches, specs, non-terminated lines, unconnected components, flow direction, conflicts for off-page connectors, orphaned annotations, and unresolved off-page connectors. For 3D piping, disconnected ports, placeholder parts, and mismatched properties. A lot of times these kind of get looked over due to as builds and things that we build that are very specific that may not be connected up. But the good thing about this one is the 3D modeling to P&ID checks. The tagged inline items for 3D model that are not in the P&ID drawing or vice versa. Properties have different values in the P&ID drawing than the 3D model, which is a very important one. And another good one is equipment in a 3D model that may have more or fewer nozzles than depicted in the P&ID drawing. For Revit, we gave it a 1.5 out of 5. It is limited to verifying properly connected pipes and system assignments, with just a very easy click of the button, it's able to go through, but it's just not as extensive as Plant 3D. Next, we have static P&IDs. For Plant 3D, we gave it a 5 out of 5 as it is built on top of AutoCAD, the traditional tool of choice for this task. Companies often already have a library developed for their P&IDs. And for Revit, we gave it a 2 out of 5. Its use of drafting views and detail items. Drafting speed is typically slower than Plant 3D and less common that a library of detailed families is already developed. Next, we have the smart P&ID functions. So for Plant 3D, we gave it a 5 out of 5. It supports smart P&ID, providing intelligent diagrams. Plant 3D specifically designed for this task. As you can see here in the properties populated, you have a lot of detailed information you can give to each piece, whether it be an inline component, a piece of equipment, the actual line itself, a valve, or instrument. You're able to fill out and populate all of this information and use it later on inside of the data manager, which is very helpful when dealing with very large takeoffs and line lists. But for Revit, we gave it a 0.5 out of 5 as this feature is not available at this time. Next, we have the P&ID line list. For Plant, we gave it a 4 out of 5. P&ID line list allows users to automatically place piping components that are in the P&ID. Possible to configure which properties transfer from the P&ID to the 3D model. So as you can see here with just this valve, you're able to transfer over the size or the status, the supplier. You have a lot of options that you're able to transfer over when creating from the P&ID side to the 3D side. And for Revit, we gave it a 0 out of 5 as this feature is not available. But for a P&ID modeler available for ABC Pro users, but that just grabs the P&ID from the Plant 3D. Plan design with fresh software installs. For Plant, we gave it a 5 out of 5. The program is designed for piping design, multiple specs to pick from consisting of many different piping components such as supports, valves, elbows, T's, reducers, instruments, flanges, and more. Components organized by class with different properties already created, such as line numbers, manufacturer, spool number, and end types. Existing wizards for equipment and nozzle placement. P&ID can be used for placement of 3D components as well. For Revit, we gave it a 1.5 out of 5 as a program designed for building design. While piping is a part of this, in plumbing, the software does not specialize in this task, and more effort will be needed to create a Revit template for this task. Pipe types will need to be created and families loaded into the Revit model. Creation of new parameters needed, such as line numbers, tags, manufacturer, spool number, facings, and schedules. Creation or download of and loading of piping components and equipment needed. So for work sharing, we gave Plant a 1.5 out of 5. Plant 3D is built on AutoCAD, and the limitations of one user per drawing still exist, even when the project is hosted in the Autodesk Construction Cloud or ACC. Files can still be accessed by other designers as read-only. A workaround is to create multiple drawing files of the plant referring to different plant areas and externally reference these files so that more designers can work in the same Plant 3D project. So we gave the nod to Revit as it is a 5 out of 5. Revit has workshare capabilities when enabled. Multiple designers can work in the same model at the same time. Each designer uses a local model and they synchronize their changes to the central file. So for Revit, it is very one-to-one. Any changes made are pretty seamless and everybody's able to see them at the same time. Next, we have piping connection settings. For Plant 3D, we gave it a 5 out of 5. Plant 3D components have end types assigned to them at their ports. Different end types can be used to make a valid piping connection, such as threaded male pipe connects to a threaded female pipe. Plant 3D can create compound joints where when two end types are joining, intermediate connections parts are automatically added, such as couplings. Plant 3D can set property matching requirements for piping connections to be established, such as flanges can connect to each other if the size, pressure class, and facing properties match. For Revit, we gave it a 2 out of 5, as Revit does not have as much granularity when it comes to connection settings. The software will use the part selected for the pipe type and does not do property check between connected components. So as you can see here, once PVC is connected and we have our sizes, everything else is pretty standard and static. You go through and make your selections, and it only creates that which you selected. As for Plant, it goes through a list and you're able to set things by priority or to set up a situation of what you would like component-wise to display when you're creating. As you can see here, for some simple joints, we have flanges. Like stated, you're able to set the end types, flange to flange, and then to select the fastener, whether it be gasket and bolts or just a gasket. For compound joints, you're able to modify and make connections to connecting parts such as couplings. And then for modifying joints, the parameters we were speaking of, when you're able to select what will be used for things to be matched together. You can use things like manufacturer or what may have you. So if those components don't match up, it will not place those two items together. Next, we have piping branch table. For Plant 3D, we gave it a 4.5 out of 5. Specs can be configured to pick apart, use priority for different pipe branches, such as the image below. The reducing T has top priority, followed by a T and a reducer, followed by a stubbing connection. As you can see here, this is what I was speaking of, being able to set the priority list or to turn off an option. If you're building something and we say, hey, the reducing T is going to cost too much money, we can just turn it off or move it down the priority list. So maybe it's only a specialized order. And then we go with the second priority, which would be a T and then a reducer. For Revit, we gave it a 0.5 out of 5. Revit does not have this feature. preferred component placement for different pipe branches is mostly a manual process. In this portion here, this is the piping branch table. I'll show this later on in the live example once we get into the spec editor, but just a brief overview. As you can see, the two connections, as this one has a lot of connections between 1/2 inch all the way up to 24 inch. Once you see the two sizes you would like to connect, let's just go for 6 and 12 here. You're able to see the different connections available, and you're able to set that priority list accordingly to what would be best for you. So next at this time, I will go ahead and pass it to my co-host, Paulo, and we'll start speaking on other features.
Thanks, Javier. All right, so now we're going to be talking about other features, a brief comparison of some features that both programs support. So before, Javier talked about program deciding features, so those ones are like the make it or break it. When it comes down to picking our software, these ones are supported somewhat by both programs. And again, this is just a reminder that these are just our personal opinions on the subject, and your experience may be different. So obviously giving scores like this, it's a very subjective task. All right, so over here we have project phases. Plant 3D, we gave it a 2 out of 5. So it still does it, but we gets a 2. Possible to do it through layering or class definition properties. So over here in the bottom, we're looking at a Plant 3D image in the project setup, and you can create a phase. So that's through class definition properties. You can also set up layering, which is a more traditional approach for project phasing. In Revit, we gave it a 5 out of 5. Built-in features, detailed management of project phase and timelines. So in Revit, the elements that you select, the families, they have the phasing tab over here. And you can set what phase you want. So this is inside of Revit. And then over here, you can control how many phases you have. So for example, if an object or an element is added to the demolition phase, then that would show as a dashed line if you're showing that particular phase. Piping components. So Plant 3D, we gave it a 5 out of 5. So this is another feature where Plant 3D shines. Plant 3D organizes piping components into specification files. The software also includes a separate application specifically for creating and managing these specs. The spec editor. Javier is going to do a quick demo on the spec editor later on. So this is where you manage your specs. Revit, we gave it a 1.5 out of 5. Piping components are organized as pipe types, not as granular as the spec editor in Plant 3D. So you can still add the components. So you just go to the pipe type in Revit in the project browser. You open the pipe type, and then you can edit routing preferences, and over here, then you can add the components that you want to your pipe. So this is kind of like similar to a spec. You can have more than one component for your pipe type, but you just do not have the level of detail that you can do, the work that you can do with specs in Revit. Structural design for piping, example, racks or piping racks. So Plant 3D has just some very basic tools for structural design. So it's conceptual design only. You can place beams and columns. You can create parametric railings, ladders, and stairs. There's some interoperability with Autodesk Advanced Steel, or more like an export to Advanced Steel. But Advanced Steel itself is in maintenance mode, but it's still a powerful software that is used for fabrication, steel fabrication. Minimal steel editing features, no steel connections. In Revit, we gave it a 4.5 out of 5, conceptual and detailed design. So in Revit, you can do a lot more than in Plant 3D. Placement of beams and columns, creation of steel columns, trusses, braces, beam systems, dozens of steel connections. You can create a automated graphical column schedule. So you just, with a click of a button, you get the column schedule created for you in Revit. You can do steel parametric cuts. There's interoperability with Autodesk Robot for structural analysis. So this is engineering software that Autodesk provides and comes with the AC collection. And you also have the advanced steel add-in, so you can install that for interoperability with advanced steel. Interoperability. So Plant 3D to Revit, we gave it an overall score of 2.5 out of 5. So this is how good is the interoperability between these two software together. So this is the overall score. When it comes down to the different programs, Plant 3D gets a 0. Plant 3D does not have an export feature of plant models, DWGs to Revit. So again, this is when DWGs go to the Revit model. So these images are actually inside of Revit. Revit, we gave her 3 out of 5, capable of importing DWG files into Revit. Sanitization of data is often necessary, but 2D lines become Revit lines, typically used for drafting views. So this is usually when you have a 2D detail and you have it in AutoCAD and you want to bring it to Revit, and you can import that DWG right away. So that interoperability is really good because you convert something in a DWG into the Revit model. And then you just need to clean the data so that the line style, for example, don't show layers and instead show what your styles are in Revit. Capable of live linking DWG files, changes made in Plant 3D will show in the Revit model automatically. So this is probably the main one. No need to export the DWG into RVT format. So, and this is actually what we're looking at over here is a live link of a model that was created in Plant 3D and then brought into Revit. So you just link the DWG. You go to Revit, click to link, and you link the model. Some Plant 3D components show as wireframe in the Revit model. So this is what we're seeing over here. So there is wireframe. Plant 3D data can't be accessed inside of Revit. So while you can bring the Plant 3D model into Revit, and people often do that, you're not going to be able to see, oh, what's the size of this elbow? You'll have to see inside of Plant 3D. And some Plant 3D component, a workaround can be to superimpose an NWC file with the linked DWG. So this is the ribbon in Revit. And when you link to the live link, you click this button. You can also bring an NWC file, so a Navisworks file, using the coordination model. So a workaround to fix this wireframe is to superimpose an NWC file with the link DWG. The NWC file will need to be manually exported if using NWC out command. So this is a utility that you can install for AutoCAD or Plant 3D. Or if using NWCs created by Navisworks. So if you have a coordination model in Navisworks, then you just need to open that Navisworks model. That Navisworks model, when it opens, refreshes the NWC, so you do not need to go to Plant 3D and do the NWC out command because it manually refreshes that model for you. So just some workarounds. So this is interoperability Revit to Plant 3D. So now it's going the other way around. So you have a Revit model and you want to open it inside of Plant 3D for coordination purposes. And this is when you're working with both tools at the same time. The overall score gets a 2 out of 5. And for Plant 3D, you gave it 0 out of 5. Plant 3D is not able to open directly, import, or link Revit files. For Revit, we gave it a 4 out of 5. Revit has built-in features to export RVT files to DWG. Manual export is necessary, though resulting in a lower interoperability score. So over here, this is inside of Revit. And this tool is actually pretty good when it comes down to export RVT file to DWG. So for example, you have the Revit categories, and you can tell the software what layer they will go to Plant 3D or AutoCAD. But because it's a manual process, then that 4 becomes a 2 because it's time consuming to manually export. Every time you want to see changes inside of Plant 3D, you have to go Revit and export that. So we gave it a 2 out of 5. Static components creation. Plant 3D, 4 out of 5, capable of using 3D models to create piping components. So what we mean by static components creation is something like if you have a 3D model, you downloaded it online, for example, and from a manufacturer's website, step file or something that was created in some other software like Inventor. So in Plant 3D, you can easily convert that into a piping component. So this is a strainer. It's actually showing as, or maybe it's a check valve, not sure. But over here, it's set as valve. And then you, over here, just set the different properties and the flange, and then you create your component. In Revit, we gave it a 3.5 out of 5. Typically, Revit families are parametric models, but static components can be created as well. So this is also a static model. For example, it is possible to use step files from a manufacturer's website and add connectors to the 3D model. So this is all static, but then we add a connector, and then you can route pipe from that static model. Parametric component editor. Plant 3D, so Plant 3D got a 1 out of 5. So as Javier mentioned before, Plant 3D comes with a very extensive library of generic models. But if you need to create a generic model that is not in the library, and there is a lot, but if you need to create a new one, and Plant 3D comes in an extensive library of piping components, but if a new parametric shape needs to be created, coding is necessary. So here, you just have the code for creating, in this case, a reducer. So you might want to use a parametric component instead of a static component if, for example, there's many different variations. So one single Plant 3D part, like a T or a reducing T, could have hundreds of components. So a 10-inch T could reduce to 2 inches, could reduce to 4 inches, 6, and so on. So instead of adding hundreds of static components, you might want to create that parametrically. In Plant 3D, you'll be looking at doing some coding. In Revit, we give it a 5 out of 5. Revit has a powerful family editor with different templates depending on the parametric model that needs to be created. Easy to test family, flex parameters, placement of planes and dimensions, easy creation of the parametric 3D model using typical 3D modeling buttons, such as extrusion, sweep, revolve, void, etc. Formulas can be used for different parameters and pivot tables, visibility settings control for different detail levels. And I'll just show a tiny little bit of the family editor if there's time at the end of this presentation. Parametric equipment and nozzle editor. So for equipment and nozzle editor, Plant 3D, we gave it a 3 out of 5. So for components like valves, reducers, T's, you add them from the spec editor. For equipment in Plant 3D, you do it from inside the software. So 3 out of 5. Plant 3D has wizards to create different equipment and placement of nozzles. So here we have the wizard to create a piece of equipment. You can also add some basic shapes to create a piece of equipment and save it as a template. And then you also have a menu to pick from the different types of nozzles that you want to add to your equipment. In Revit, we give it a 3 out of 5. You would still be using the family editor instead of Revit. The family editor just shown can be used to create different equipment as needed. A lower grade is given in this category due to lack of pre-built wizards for this task. So because Revit is more, the family editor is to do all the families, there's no wizard for just for nozzles. We reduce that grade, even though the family editor is an awesome tool. Modeling environment. How easy is it to model piping? So for Plant 3D, we gave it a 5 out of 5. 3D modeling is usually done in 3D. View cube can be used for 2D modeling. No need to switch between different views, but feature available if needed. The existing model space is typically enough for efficient plant design. So again, a very subjective grade. So in Plant 3D, you're going to be in a 3D model, and then you're just going to route your pipe in 3D. And that will be it. There's no need to switch between views. You can do 2D if you need to. So very easy to route pipe in Plant 3D. In Revit, we gave it a 4 out of 5. Still very easy to route piping. Modeling in Revit is perhaps not as straightforward and often requires the creation of temporary section views to route pipe. Sometimes in Revit, when you're creating something, you're in a plan view, and then you're routing the pipe, and then you need to make a temporary section, for example, to then align the pipe the way that you want and to make connections, and then switch back to the plan view and so on. And because of that, we just gave it a little bit of less of a grade. It is often necessary to switch between 2D and 3D views when modeling in Revit. Sometimes possible to model in 3D, but not always. So you can also press Shift key in Revit to adjust to horizontal pipe and vertical, but don't forget to press Shift, or your pipe is going to be slightly not orthogonal. I forget the word, but it's not going to be perfectly horizontal. So it's possible to do it, but not as straightforward as in Plant 3D. Dynamo. So visual programming. So Plant 3D, we gave it a 1.5 out of 5. So Dynamo does not come with Plant 3D, but Civil 3D has built-in Dynamo. So Civil 3D is part of the AC collection. And Plant 3D and Civil 3D are both AutoCAD verticals, so built on top of AutoCAD. So using the Civil 3D application, a user would be able to automate certain AutoCAD tasks, but would not be able to automate Plant 3D specific tasks. Example, routing pipe. So you can only do the base AutoCAD, which is still a big chunk of a big portion of the Plant 3D model. In Revit, we gave it a 5 out of 5. Dynamo comes with Revit and can target specific Revit elements. It is possible to automate many different Revit tasks in Dynamo. For example, you can build walls, route pipe, place families, upgrade Revit models, etc. Dynamo can be used for generative design tasks and to create user-friendly applications. So here we just have what a Dynamo graph looks like. So this is programming for designers, and we call it visual programming because you just drop the nodes and then you connect the nodes with lines. Depending on the node's task, then you get a certain output. And with that, you're able to automate tasks in this case in Revit. Over here, we have an image of the Dynamo player. So once the script is created over here, then to add levels, for example, this is the one that we're going to be showing. This little bit of automation creates a series of levels above or below the selected level. So a seemingly very easy task, but if you need to do it very often, so repeat it multiple times, then a script like this will save you a lot of time. So you just select, in this case, the distance from the selected level, and then this will create the levels for you. So this one comes with the samples that Autodesk provides us. Autodesk Construction Cloud Collaboration. So ABC Pro stands for Autodesk BIM Collaborate Pro. So that's one of the licenses that you can get, the one that the designers get. For Plant 3D, we gave it a 4 out of 5. Fully supported to work in ACC, so the Autodesk Construction Cloud, but XREFI models in ACC outside of Plant 3D project needs to be done using the desktop connector, which requires some setup. So there's a button for directly connecting in ACC project drawings inside of the Plant 3D project. But if you want to XREF a DWG from outside your Plant 3D project, then you need to use the desktop connector. Plant 3D does not have the capability of creating separate 3D views of a model in the project manager. So clash detection using the model coordination module. So one of the modules that comes with the BIM Collaborate Pro has limited use. For Revit, we gave it a 5 out of 5. It's fully supported to work in ACC. There's issues add-in to further enable coordination with ACC. So it's an add-in published by Autodesk, and then you can see issues, which is a feature of ACC, and you can see the issue stamps inside of your Revit model. This image over here is showing the import link Revit window. So this is a window inside of Revit. And when you go to link another Revit model, then there's a special button, the external resource button, and that lets you link another Revit model. So the downside, for example, with this one is that if you're XREFing a model outside of your Plant 3D project using the desktop connector, then in the viewer, in the docs viewer over here, your DWG is not going to show because of the way that Plant 3D does caching of the local file. So this is just the docs viewer as mentioned for Plant 3D and Revit inside of ACC. Orthographic drawings. Plant 3D, we gave it a 4.5 out of 5. Streamlined features to create orthographic drawings with bill of materials, BOMs, and annotations. So another top feature of Plant 3D. Set up a volume containing plant components and place the views in a title block. A bill of materials BOM can automatically be generated with the elements in the orthographic drawing. Annotations and dimensions can be placed directly in the title block. Streamlines placement of ID bubbles that match ID value in the BOM table. And we're going to take a look at that in the next slide. Revit, we gave it a 3 out of 5. Capable of creating orthographic views with schedules, BOMs, but process is not streamlined like in Plant 3D. Shared parameters needed to be created to be able to filter components in a Revit schedule. So if you want to basically achieve the same tasks in Revit that you can in Plant 3D, you'll need to do some additional work. So you can create shared parameters to filter elements, parameters needed to be added to components for proper annotation, and you'll need to create some tags to retrieve the information that you need. So here it is orthographic drawing. This is another one of the main deliverables of Plant 3D. The other one being the isometric drawings that Javier showed. So here we have our 3D model and we select a volume of our plant, and whatever is inside of that volume then gets grabbed, and we're able to automatically generate this bill of materials. This bill of material has an ID number, and then there will be features on your just right-click your button, right-click your mouse, and you can annotate the drawing. In this case, we just added some center elevations. You can also add the ID bubble to point to the different components of your Plant 3D model. And you can add dimensions as well. So it's very straightforward how to create this drawing and quick. Systems. Plant 3D, we gave 0.5 out of 5. Plant 3D can isolate systems by layering our custom properties, but this is not as streamlined as in Revit. This image over here is in Revit, instead of Revit. In Revit, we gave it a 5 out of 5. So systems, something that exists in Revit. Systems allows users to see what piping loops exist in a model, quickly determine equipment missing connections, easily isolate elements belonging to a specific system, automatic pipe routing of elements in a system, system browser palette for piping loop insights. So over here, we have a system. This is the domestic hot water system. So the system browser basically lets you select the system and the components that belong to it get selected. In this case, hot water, so for all these sinks. But as we know, sinks also have cold water and sanitary drain. So with this window, you can quickly see what belongs to this one system. So when you're wanting to do the pipe loops, maybe you can have two systems, or in this case, just one. And then there's going to be one for cold water. And if there's the sink could show over here as unassigned, for example, if we didn't set cold water sanitary for that particular system. Export to FC, Plant 3D 0 out of 5. Feature not available, Revit 5 out of 5. Capable of exporting to FC, format, and mapping element categories to FC categories. So these two windows are in Revit, and we have multiple options to configure the IFC output that we can get from Revit. So just the way that over here it's showing the mapping of Revit categories to the FC categories. Pressure drop and flow analysis. So Plant 3D, we gave it a 0 out of 5, which are not available in Plant 3D. These images are from Revit. Revit, we gave it a 5 out of 5. The program can assist with pipe sizing by offering insights for pressure loss and flow calculations. So usually, instead of the mechanical settings window, it shows in the calculation for piping or for ducts. You can do pressure drop calculations, or the software will automatically calculate for you if you meet the requirements outlined in the window. It's obviously not like a replacement for engineering calculations, but it could be maybe like the first step to determine pressure drop. So Revit has that capability. So now here we're going to go into some live demos, some of the best features of Spec Editor and Revit families. And with that, I will pass the screen to Javier.
Thank you. Here we have the Spec Editor for Plant 3D. This is a program that comes with Plant. Once you download it, it's a standalone program. As you can see, you have the option to create a new spec or create from existing. The good thing about once you create is you can build on top of an existing spec, which is awesome. So if you have worried about standards and things like that, you can start with the basics. But we'll just take a look at the carbon steel 150 just for time's sake. As you see here, this portion at the top is the complete spec in its entirety that is available in Plant 3D. If we wanted to add something, we could come down here to the catalog and search. So if we wanted to add, let's just say this 1,500-pound plug valve, a simple click and add to spec adds it to the spec that easily, as you can see right here. And if we wanted to remove said valve, simple click of remove spec. So once you've saved here inside of the spec, and you go back into Plant 3D, if you reload the spec or open a new drawing, all of the changes will show and all the changes will be available. What I also would like to show here, if you see this caution triangle here and these green circles here, what this is that priority list we spoke of earlier. So I can go to a certain size, let's just say for 6-inch, this is an elbow. If we wanted to use, for some reason, 90s cost way more than 45s. And so for every chance we give, we want to run 45s instead of 90s. I can simply just move it up and down the priority list to reflect what we needed to use first before having to order a specialized piece or a piece that costs too much. Other feature I would like to show is the branch table editor. As I shown earlier, these are the sizes that this spec goes from 1/2 inch all the way up to 24. So again, if we wanted to go from 2-inch to 10-inch and to see what was available, we have a stub in, a sockolette, and then we have T's, reducers and T's, all these turned off. But if we knew, hey, there's a company who's selling one and it's affordable as opposed to a sockolette and then running pipe through it, we could simply just add it and then move it up the priority list so that when drawing and designing inside of Plant with piping, it will then put the T and the reducers in first versus trying to do a sockolette. The last part I would like to show you is the catalog editor. Down here, all of these come out of the box with Plant 3D. So if you needed to make a change to, let's just say, this pressure relief valve, for some reason, we needed a bit longer or port a little bit wider, you have the option to duplicate it and then make changes. But if we spoke to a company and they said, hey, we're going to sell you a new valve that would blow our minds and be cheaper than all the rest, then we have the option to create a new component with static 3Ds that are available. And there's a wide variety of different options for the static images. So if we go down here and we'll just grab a butterfly, we'll give our sizes and create it. Now we have the option to add all of that information from those cut sheets we get from vendors. And if we wanted to get very detailed and specific, we could go over to the sizes, and for each particular size, You could go in and add all the dimensions for different lengths or port sizes. For some reason, hey, this one was going to be a foot long, but it was going to be cheaper than all the rest. We're able to put that information in, and once we save it to the catalog and add it to the spec, anytime in Plant, we're able to go back in and place this valve multiple times without having to create a new valve each time for a very specific one. And again, if you had multiple cut sheets you were getting from different vendors and things like that, and you want to know what would work better, you can, this is kind of infinite. You can add as much as you want to the catalog and add or remove from the spec as you will. So those are just some of the prime features I wanted to show you in Spec Editor. The last portion will be the Revit families that Paulo will show at this time.
Thanks, Javier. All right, so we're going to be looking at Family Editor, and then I see that you guys have a lot of questions. We'll be answering that at the end. So over here, we just have the sample for plumbing provided with Autodesk for 2025, the Snowden Tower sample plumbing. So over here, there's a valve. So if you select it, we have a gate valve, and with any family in Revit that is a component family, you can just double click it, and then that takes you to the family editor, which I already had open. So we can see over here at the top the name of the family, and it's a RFA file. So the family editor is amazing for creating parametric families, as previously mentioned. So if you want to create a new family in Revit, you just go to New, and then you click Family, and then there's a lot of different templates to pick from. And depending on the template that you select, then you're going to get a specific user interface for that particular family. So creating a family in Revit, a parametric family, is pretty much always the same. You create planes, you add planes to your model, and then you add labels. So you add dimensions between the planes. And that's usually what we call the skeleton of a family. So you have the planes. And then once a plane is added, then you go to the Create tool, and you select one of these forms to create the 3D model. So we're currently looking at this particular family from the top view. We can also go and look at it from 3D. So for example, if we just double click on this flange for the gate valve, we can change the scale over here. And this is actually an extrusion that happens probably in the left plane and the left view. And it's a circle, and then just there's over here the extrusion start and the extrusion end. That sets the thickness of that family. And there's a dimension for the radius of this, and it's the height for this flange in particular. Let's cancel out of there. So with all of these parameters and dimensions that we're looking over here, in Revit, if you click this family types button, then you get this window, and this is where we control our parameters, and then we can set formulas so that the elements can be communicate with one another. So for example, stem height is grayed out because it's the value comes from a formula, which is open height minus the normal radius divided by 3. Because it's parametric, then you can just add the different sizes. So at the moment, we're in a 2-inch family. Let's maybe go 3D first. And then if you switch to 8-inch family, then you click apply, and the family changes, so just by changing the parameters. So the family editor is a really good tool to create parametric families, and it will make your life very easy when modeling inside of Revit. So that was the spec editor before. This is the family editor. Over here, in conclusion, we have all of our grades that there's a lot of different, there's a lot of features that we didn't compare. So this would be, the list is already long as is, and it could be much longer. But over here, we have the overall scores that we gave. We also have another one called time to learn. So we gave Plant 3D a 4.5, and Revit F4. So Plant 3D is perhaps a little bit easier, but again, easier to learn. But again, very subjective grades, like all of them. I cannot emphasize this enough, that this has been my experience and Javier's experience as well. And you guys probably would have a very different grades than what we gave. If you have any questions or want to talk about how this comparison applies to you and your company, you can give us a call. We only covered the out-of-the-box features for the software, and there's add-ins for both Revit and Plant 3D that further enhance the capabilities of the software. So for example, over here we have Revit is not doing ISOs, but maybe there's an add-in out there. We're not talking about those today, but that feature could be done with a free or paid add-in, for example, and that could be with any of the functionality that we're talking about. So just to wrap this up, the main features for Plant 3D is a piping design software. Revit is a BIM software, so made for buildings, and plants can be a building, but Plant 3D is specialized for this type of task. So it creates isometrics, for example, and you have P&IDs. So if your project has P&IDs and isometrics, then just based on these scores, then we're looking, and Plant 3D might perhaps be the tool of choice. So over here now, thank you. Now we're going to go to questions. If you have any outstanding questions after this webinar, you can go to this website, imaginit.com, contact us, or send an email or the phone number.